Someone asked me the craziest thing this week. How if humans lived on Mars without spacesuits? And I had to find out. You wake up one morning not on Earth but on Mars. And not in some cozy space station or a futuristic dome city. I mean Mars, raw and bare, with no spacesuit, no helmet, not even an oxygen tank. Just you, your body, and the red planet. The first thing you'd notice is silence. No birds, no cars, no wind the way we know it. Just stillness, broken only by the sound of your own heartbeat. Which, by the way, would be racing. Because within seconds your body would realize something is very, very wrong. See, Mars looks like it might be livable. There's ground, there's sky, the horizon even kind of looks like a desert on Earth. But that's the biggest trap. The air here isn't like Earth's. Instead of a breathable mix of nitrogen and oxygen, Mars' atmosphere is about 95% carbon dioxide. That's like walking into a room filled with exhaust fumes and trying to breathe it like normal air. Only problem is it's even worse, because there's barely any air pressure at all. On Earth, the weight of the atmosphere pushes down on us with about 14.7 pounds per square inch. You don't notice it because your body has evolved to work perfectly with it. On Mars, the pressure is less than 1% of Earth's. It's like being at the top of Mount Everest times 30. If you tried to take a breath here, your lungs wouldn't fill with oxygen. They'd collapse inward like balloons being sucked flat. And if you held your breath? Even worse. The low pressure would cause the air inside your chest to expand, tearing delicate lung tissue. So the very first thing that happens when you step outside on Mars without a suit, you can't breathe. Within 15 seconds you'd be unconscious. But that's just the beginning. Here's where it gets wild. Your blood doesn't boil away instantly like in some sci-fi movie, but it does start to fizz. Literally fizz like soda when you pop the cap. That's because the low pressure makes the water in your body start to vaporize. The moisture on your tongue, the wet surface of your eyes, even your saliva would begin bubbling. Imagine the unsettling sensation of your spit suddenly boiling in your mouth, not from heat but from lack of pressure. Now let's talk temperature. Mars isn't just cold, it's freezer-level brutal. Average temperatures hover around -80 degrees Fahrenheit, and at night it can plunge below -180. Step outside naked, and within minutes your body would lose heat faster than you could ever generate it. Your skin would start to freeze, frostbite setting in on your fingers, toes, nose, and ears almost immediately. But here's the twist. In those first few minutes, freezing isn't even your biggest problem. The real killer is still suffocation. You'd pass out long before you froze solid. Radiation adds another layer of disaster. Earth's magnetic field and thick atmosphere protect us from harmful cosmic rays and solar radiation. Mars doesn't have either. That means standing unprotected on Mars is like sunbathing in the middle of a nuclear power plant during a solar flare. Over the long term, this radiation would rip through your DNA, dramatically increasing your risk of cancer and cell damage. But again, you wouldn't live long enough for that to matter unless we imagine some way you could survive the first few minutes. Okay, so far, Mars without a suit is instant doom for one person. But let's scale it up. Imagine if an entire group of humans suddenly found themselves there trying to live on Mars bare-skinned. The first thing you'd notice is chaos. People would be collapsing in seconds, their bodies gasping uselessly at the thin carbon dioxide atmosphere. If they were close together, you'd see something eerie, their breath creating faint, ghostly clouds in the frigid air. Except it wouldn't last because they'd all fall unconscious almost immediately. Within minutes, silence again. A colony wiped out before it even began. But what if we stretched the rules of this what-if scenario? What if, somehow, humans had the ability to survive longer than 15 seconds? What if we had some genetic tweak that let us withstand low pressure, or a physiology more like certain animals on Earth? For example, some frogs and turtles can survive without oxygen for hours by slowing down their metabolism. Or think about the tardigrade, the famous water bear, that can survive the vacuum of space. If humans somehow borrowed tricks from these creatures, maybe we could last longer out there. Let's imagine it. You're still gasping for air, but instead of blacking out instantly, your body finds a way to adapt. Maybe your skin thickens slightly, protecting you from the cold and radiation. Maybe your blood chemistry changes, allowing oxygen to bind more efficiently and carbon dioxide to be less toxic. It's science fiction for now, but not impossible to speculate. After all, evolution has pulled off stranger tricks. If we survive the first 5 minutes, then we'd really start to see the long-term problems pile up. Your skin, exposed to the low pressure, would swell. Not pop like a balloon, sorry Hollywood, but definitely puff up like you were slowly inflating. Your joints would stiffen, and every movement would feel like wading through molasses. You'd be walking across a frozen desert, gasping for air, skin bubbling slightly, eyes stinging from boiling moisture, while radiation microwaves your cells. Honestly, not the best Airbnb experience. But let's pull back for a second and zoom out. On a human scale, it's deadly. On a city scale, it's impossible. Imagine building a town on Mars with no protective domes, just humans trying to stroll around in shorts and t-shirts. Buildings wouldn't help much because without air pressure, you couldn't just trap oxygen inside. It would leak out constantly like trying to inflate a balloon full of holes. Fires wouldn't burn, they need oxygen. Water would boil away instantly. Even cooking food would be a nightmare. In fact, the very idea of daily life on Mars without suits falls apart at the most basic level. Breathing, eating, sleeping, none of it works in this environment. And yet the idea is so tempting. Mars is right there, tantalizingly close in cosmic terms. It's the most Earth-like planet we've found, with days almost the same length as ours, seasons, polar ice caps, and even evidence of ancient rivers. So the question becomes, is there any way humans could ever live there without being wrapped in layers of technology? That's where things get interesting. Because while the immediate answer is no, science might have some wild ideas up its sleeve. And here's the twist, we're not done yet. In the next part, we'll push this even further. If humanity really wanted to adapt to Mars without spacesuits, what extreme changes would we need? Could we genetically engineer ourselves into Martians? Could terraforming actually make Mars breathable? And what unexpected consequences would come from reshaping an entire planet to fit our lungs? Stay tuned, because this is where it goes from deadly science to the edge of science fiction. So, we don't give up after those first terrifying minutes on Mars. Let's push forward and ask, what would it actually take for humans to live there bare-skinned, as if it were just another version of Earth? The first option is obvious, change Mars. The second option? Change ourselves. Both ideas sound impossible, but both are worth exploring. Let's start with terraforming, the sci-fi dream of turning Mars into a second Earth. Right now, Mars' atmosphere is thin, cold, and made mostly of carbon dioxide. To make it breathable, we'd need to thicken it, warm it, and add oxygen. One way is to release greenhouse gases. If we pumped enough CO2 and other gases into the air, Mars would heat up, ice caps would melt, and water vapor would fill the atmosphere. Sounds good, right? Except scientists have done the math and there just isn't enough CO2 on Mars to do the job. Even if we released every bit trapped in the rocks and ice, it still wouldn't give us a breathable sky. You'd still walk outside, take a deep breath, and collapse. Okay, what about nukes? Believe it or not, this is an actual suggestion. Detonate thousands of nuclear bombs over the polar ice caps, release the carbon dioxide, and supercharge the atmosphere. Boom. Mars warms up. Problem is, again, the math doesn't work. You'd make Mars temporarily warmer, but it wouldn't last. The atmosphere would slowly escape into space because Mars doesn't have a strong magnetic field to hold it in. It's like trying to fill a leaky balloon. No matter how much air you blow in, it keeps seeping out. So if terraforming isn't practical, maybe we go smaller. Maybe we don't change the whole planet, maybe we change just us. What if we genetically engineered humans to survive Mars' brutal conditions? Imagine if your lungs were redesigned to pull oxygen out of thin air, like the way certain microbes can survive in near-zero oxygen environments. Imagine your skin thickened and darkened to shield against radiation, like a natural space suit made of living tissue. Maybe even transparent eyelids that protect your eyes from ultraviolet rays, while still letting you see. It sounds like superhero-level science fiction, but genetic engineering is advancing fast. We already tweak crops to survive droughts and modify bacteria to eat oil spills. Could we one day tweak humans for Mars? Here's where it gets even crazier. What if, instead of trying to breathe oxygen, we just stopped needing it? Some organisms on Earth don't use oxygen at all. They rely on other chemical reactions to power their cells. If humans could evolve, or be engineered, to function without oxygen, Mars' carbon dioxide atmosphere might not be instantly fatal. You wouldn't be comfortable, but you might not be dead either. Of course, this raises huge ethical questions. If we genetically engineered a human to survive Mars, are they still human? Or would they be something else? A Martian species, cousins of ours but not quite us anymore? And what happens if those Martian humans come back to Earth? Would they even be able to survive here, or would Earth's atmosphere feel toxic to them? Suddenly, we're not just talking about colonizing Mars. We're talking about splitting humanity into two branches of evolution. But let's zoom out again. Imagine, just for fun, that humans did adapt. Let's say our descendants are strolling across the Martian desert without suits, lungs somehow pulling oxygen from the thin air, skin shrugging off radiation like armor. What would life look like then? For one, the sky. On Earth, sunsets are red because the thick atmosphere scatters blue light. On Mars, sunsets are blue. So a Martian kid might grow up thinking blue sunsets are normal and red ones are strange. Days would feel familiar, 24 hours and 37 minutes long, but gravity would feel off. Mars has about 1/3 of Earth's gravity, so people would walk differently. Jumps would be higher, running would feel like bounding across a trampoline, and even sports would look alien. Basketball? Forget dunking, everyone would be dunking. Long jump records? Shattered instantly. A normal human leap on Mars would look like superhero flight. Cities would sprawl differently too. With less gravity pulling everything down, buildings could be taller and thinner. Transport could be more vertical. Imagine elevators stretching hundreds of meters high, or people casually hopping between platforms without fear of breaking bones. But there's a catch. Weaker gravity would also weaken muscles and bones. Martians might end up looking lankier, with thinner frames adapted to lower gravity. A person born on Mars might never be able to return to Earth. Their body simply couldn't handle the crushing pull of 1G anymore. And then there's agriculture. On bare Mars with no oxygen, no suits and no protective domes, plants as we know them can't grow. But what if we engineered plants the same way we engineered people? Imagine crimson Martian forests with leaves designed to survive on carbon dioxide alone, pulling water from the ground and shrugging off ultraviolet radiation. Instead of green fields, you might walk through alien-looking landscapes of red and purple plants, adapted for a sky we'd find toxic. Over thousands of years, Mars could become less of a second Earth and more of its own distinct biosphere. Humans wouldn't just live on Mars, we'd evolve into something new alongside it. The line between survival and transformation would blur, and eventually, Martians might look at Earth humans the way we look at Neanderthals. Relatives, sure, but clearly different. Here's the wild twist. If humanity really did split this way, Mars might not just be a colony. It could become a whole new cradle of civilization. Martians would develop their own culture, art, and ideas shaped by a world with blue sunsets, weaker gravity, and a sky that never feels safe to breathe. Wars, alliances, trade, all of it could play out between two versions of humanity separated by millions of kilometers of space. And yet, all of this started with one simple question. What if humans tried to live on Mars without spacesuits? The short answer is, you'd be unconscious in 15 seconds and dead in a couple of minutes. The long answer is, it forces us to imagine the incredible challenges of leaving our home planet, and the even more incredible possibilities of adapting to new worlds. Whether it's through terraforming, genetic engineering, or thousands of years of slow evolution, the idea is both terrifying and exciting. So the next time you look up at that tiny red dot in the night sky, remember, it's not just a planet. It's a mirror for our imagination. It dares us to ask not just, could we go there, but what would we become if we did? And that's the real question. Are we ready to stay human, or are we willing to become something else entirely just to keep walking under alien skies? If you enjoyed this journey into the impossible, let me know in the comments what other what-if scenarios you want us to explore. Don't forget to subscribe for more deep dives into the weirdest, wildest corners of science and imagination. Because here on How If, the only limit is how curious we're willing to get.